Namaskara, welcome to Tech Girl Kannada YouTube channel.
Advantages and disadvantages of divide and conquer. Advantages: difficult problem is broken down into subproblems and each problem is solved independently. Subproblems can be executed on parallel processors. Divide and conquer helps in discovery of the efficient algorithm. It also uses memory caches effectively. A reason is when the subproblems become single enough, they can be solved within a cache without having access the slower main memory, which saves time and makes the algorithm more efficient. Disadvantages: large number of sublists are created and need to be processed. Make use of these recursive methods. Recursion is slow and complex. Once the problem is broken down into subproblem, the same subproblem can occur many times. Decrease and conquer now. Decrease and conquer technique is based on the exploiting the relationship between the solution to a given instance of problem. There are three major variations of decrease and conquer. Decrease by constant value 1, decrease by constant factor, or variable size decrease. The size of the instance is reduced by the same constant on each iteration of the algorithm. Typically, this constant is equal to 1, that is insertion sort. Second one is suggest reducing the problem instance by the same constant factor on each iteration of the algorithm. In most applications, this constant factor is equal to 2. Example, topological sort. The size reduction pattern varies from one iteration of the algorithm to another. That is an example is Euclid algorithm for computing the greatest common divisor. Topological sorting, linear order of the vertex. Difference between directed and undirected. An adjacency matrix of a directed graph does not have to be symmetric, but an edge in directed graph has just one, not two, corresponding nodes in the digraph adjacency list. Tree edge, there is the back edge, forward edge, cross edge. Forward edge, that is the back edge, like that back edge from vertex to their ancestors, forward edge from vertex to their descendants in tree other than their children. Then from back edge in a DFS forest of a directed graph can connect a vertex to its parent. Presence of the back edge indicates that the digraph has a directed cycle. The directed cycle in a digraph is sequence of 3 or more of its vertices that starts and ends with the same vertex, and in which every vertex is connected to its immediate predecessor by an edge directed from the predecessor to the successor. Example is course and prerequisites. List the vertices. The vertex where the edge starts is listed before the vertex where the edge ends. This problem is called topological sorting. The problem cannot have a solution if a digraph has a directed graph. For topological sorting, the digraph must be DAG, that is directed acyclic graph. There are two algorithms, depth first search and the source removal method. Directed acyclic graphs. Depth first search. Performs a DFS traversal and note the order in which vertices become dead ends popped off the traversal stack. Reversing this order yields a solution to the topological sorting problem. No backedge has been encountered during the traversal. If the backedge has been encountered, then the digraph is not a DAG and topological sorting of its vertices is impossible. Source removal method based on the direct implementation of decrease and conquer by one repeatedly identify in the remaining digraph a source which is a vertex with no incoming edges and delete it along with all the edges outgoing from it. If there are several sources, break the arbitrary into, and if there are none, stop because the problem cannot be solved. The order in which the vertices are deleted yield a solution to the topological sorting problem. The solution obtained by the source removal algorithm is different from the one obtained from the DFS based on this algorithm. Both of them are correct. Topological sorting problem may have several alternative solutions. Instruction scheduling in program compilation, cell evaluation ordering in spreadsheet formulas, resolving symbol dependencies in linkers. In construction, research and software development involve a multitude of interrelated tasks with the known prerequisites. Source removal method, that is in degree 0. DFS is the short form of first vertex and use stack. Topological sorting, the topological sort of a directed acyclic graph DAG G equals to V comma E vertices and edges is a linear ordering of all the vertices such that every edge U comma V in the graph G, the vertex A appear U appears before the vertex V in the ordering. A topological sort of a graph can be viewed as an ordering of vertices along a horizontal line so that all directed edges go from left to right. For a cyclic graph, no linear ordering is possible. If A depends on B and B depends on A, then it is cyclic. A graph which is cyclic doesn't have the topological sequence. Methods to obtain this topological sorting is DFS method, source removal method. Get topological order using DFS method. Select any arbitrary vertex. When vertex is visited, it is pushed onto the stack. When vertex becomes a dead end, remove from the stack. Repeat 2 and 3 for all vertices in the graph. Reverse the order of deleted items to get the topological sequence. No backedge has been encountered. During the traversal, if a back edge has been encountered, then the diagraph doesn't have DAG and topological sorting of its vertices is impossible. Then let us consider a graph, that is, when you have this initial step 1 is, firstly we will be taking A as our source, applying DFS method algorithm. We will take A as the source, read the adjacent of A. There is nothing but adjacent before that. Node visited of S is A. Then for popping the stack. Then second step for A, we have adjacent as B only. Then node visited is B. A comma B pop nothing. Then for next for B we have A B, we have E. A B E, that is nothing but nothing. Then A V E, we will be popping because E doesn't have anything at the next. Adjacent of E is nothing, so we will pop E. Then again goes back to B. Then it goes to G. Maybe G, then come back. Then ABG. For G we have F as an adjacent node, so that will be taken and given. Then we adjacent of F is there is nothing, so pop F. Then adjacent of G has already taken, pop G. Adjacent of B already taken, then pop B. Then again A, we have C, so we have to add it to this node to visited. A C, then C, then A again, stack empty. So we take the next vertex in sequence which is not visited and push it onto the stack. Add to S, which is D. D, D, D. Stack is empty, so table next vertex in the sequence. The order in which the vertices are removed from the stack is obtained from the last column. From the stack is obtained from the last column popped order. E F G B A C A D, which will be the topological order is obtained by reversing the above popped orders, which is given by D to A to C to B to G to F to E. Topological sorting.
Thank you for watching. Do like, share, and subscribe to my channel.